So hello everyone, good morning. My name is Yunus and I am from India, Mumbai. We will be discussing here today MySQL high availability with asynchronous replication and using some tools, those that is Orchestrator, ProxySQL and Consul. So let me introduce about myself. I am working in Percona as a MySQL DBA2. So I have about 15 years of experience in system database administration, and I enjoy discovering open source technology, and I like to play cricket in my free time. So I would like to also introduce my friend and colleague Kedar. Actually, he was supposed to be here along with me presenting, but unfortunately he was not able to travel. But I would like to thank him a lot for contributing in this presentation. And of course, if you want to explore the Percona's lifestyle, you can scan this barcode, and if you are interested in it, you can please visit the careers page. And so the agenda about this presentation is why do we need high availability in our environment, and how do we build a highly available solution. Here we will go through each and every tool what is mentioned in the heading, and we will try to see how we include that tool in the highly available environment. Okay, so why is of high availability? Why do we need high availability? So let's try to understand why do we need high availability. So high availability is a very important part of architecture in day-to-day architecture. So it eliminates the single point of failure. So even one of the component, if one of the component goes down in our system, the entire system should not be down. So that is why we prefer high availability. And to reduce interruptions and downtime in our environment, we need to make sure that our system is actually able to cope with it, and our system is ready for highly available. And it also need, along with that, a quick recoveries during the failures. It should be able to recover by itself, and scalable to highly available traffic. Like if the traffic is high, it should be able to scale by itself. And also, of course, highly available system needs to maintain a high level of system uptime too. So factors that can affect high availability is unplanned downtimes as well as planned downtimes both. So unplanned downtimes, we can accept that we don't know when it can come, right? Hardware failure can occur at any time, software failure can occur at any time. So hardware failure, just like your server has gone down, and software failure is like your MySQL is crashed or something, or any application is crashed, it is an unplanned downtime. And the hardware maintenance, where we go with the planned maintenance. So hardware maintenance is you want to upgrade your resources on the server, you want to do some network maintenance or anything that comes under hardware maintenance. And the software maintenance is like upgrading of operating system, upgrading of MySQL, maybe any application that affect MySQL. So those comes under planned downtime. So those affects the factors. So how many nines do you actually need? So this is what high availability we measure. So but we all need 100% of high availability, but we know that it is not possible. Sometimes there are uncontrollable events as well as natural disasters which affects it. So these are all actually the calculation of downtime per year according to the how many nines do you need. So most of the companies mostly prefer to have 5 nines, at least to 5 nines or at least 4 nines to achieve the highly available environment. So how do we, let's try to build a highly available solution from here. So we will start with a single standalone server, okay. So let's consider we have a standalone server here, and it goes down, and our application will not be able to serve anything, right, because our database is down and it is a standalone. So there is no backup. Okay, we are taking the backup, but there is no replica, so that we can directly point our application to replica. So what we will do here is we will have to restore the backup, and until the restoration is finished, the server will not be available, correct? So we are having a huge downtime there. So what we will do is we will add a replica in our environment, that is asynchronous replication. So asynchronous replication is a very good way to duplicate the data, and keep the live data available along with it. So we can add multiple asynchronous replica as well, and it helps us to scale as well. We can write on master, we can read on replica, and again it helps in backing up as well. So for standalone server, we were taking backup on master, and it was affecting the performance as well. So now we have a replica, so it is advantage that we can actually back up on replica and leave our master alone for setting up, for giving us the good performance, right? So along with that, so I will also talk about GTID and non-GTID replication. So GTID and non-GTID replication, here I am talking because we will see it further. So non-GTID is actually a replication, binary log file and position based replication. So here B, for example, we have server A, and that is B and C are replicating from A, and so we need to shift this C server to B. So if we have a binary log file and position based replication, it is not possible to shift the C server to B without stopping the replication on B. That is the manually I am talking about. So what GTID does is, GTID is a global transaction identifier, and it has the transaction ID unique all over the topology. So it becomes easy with auto position as one with GTID to set to move the servers as we want without stopping the replication on the source. So MySQL was a single point of failure before, so we are trying to eliminate single point of failure. So we added a replica, and then our application was able to continue writes on it. So what we can do here to make better our environment is, like, we will fix the master, we will again add it as a replica of our new master now, and we will maintain the architecture so that whenever the same type of problem comes, we are at least having the replica ready for serving the application. So what is the disadvantage here what is the disadvantage in this environment? So we are still editing the application configuration manually, and if we need to failover for some reason, we need to do a manual failover. So manual failover is of two ways, like using a tool and doing manual failover, and using a command and doing a manual failover is different, okay? So I am talking about a manual failover using the command line. So we run the queries for failover, so it will be a manual failover and it will take some time. It is a manual effort, so it can be human error prone as well. So that is what we have a disadvantage here. So how we can improve it? So we introduce an orchestrator in our environment here for improving. So Orchestrator is actually authored by Shlomi. It is a replication topology manager. It discovers crawls through the topology, and it discovers each and every server and give us a very good graph on the web interface. So it also has a very good web interface, as well as it has a command line client as well, and it also has APIs with it. So it also has a clustering support, and we can avoid a single point of failure there. And it is again free and open source as well, available in GitHub. So prerequisite for having Orchestrator in our environment is we need a user, MySQL user for Orchestrator to connect to it and crawls to the topology and discover the replicas and make whatever. So the below you can see that there is a user created, and what all privileges do we need for connecting to Orchestrator and running all the processes in the Orchestrator. So the user is there. Now binlog and log slave updates we recommend to be enabled, so that if the binlog is not enabled, when we move out, roll the master, it will fail the failover, because if the binlog is not enabled, it cannot replicate, right? So binlog and log slave updates needs to be enabled. Master info repository needs to be set to table, so that when it does the failover, it runs the change master, it gets the credentials for it. And it also supports GTID as well as non-GTID replication. So non-GTID replication, even though movement of slave is not, it will be little complex, but still, even though you have non-GTID based replication, you can use pseudo GTID as well. So pseudo GTID is actually an injecting of empty transaction. So how does it inject the empty transaction? It is like, drop view if exist for the database which does not exist, but it is just an empty transaction that if exists just drop the view, right? So it is inserting a GTID transaction in the binary logs so that it can track the changes and it can cope up with GTID. So it also have a MySQL and SQLite backend options. We can check we can have anything with MySQL or SQLite as a backend for Orchestrator, and the best thing is that the Percona supports Orchestrator. So Orchestrator also supports highly available environment. So Orchestrator high availability can be configured in two ways. So it can be either configured by shared backends. So shared backend is like have the three node orchestrator. So 3-node orchestrator can have a shared backend, a single backend that can be a Galera cluster, that can be a PXC or NDB cluster, Percona Extra DB, I mean, and okay, so this can be. So if you don't want to maintain the database for Orchestrator as well, then you can actually choose Orchestrator raft method as well. So Orchestrator raft method is it uses a raft consensus algorithm for maintaining the high availability. So what it does is it uses a raft protocol, Orchestrator all the 3 nodes, and form a consensus to decide which one is the leader. And once it elects the leader is actually responsible for doing all the changes and to replicate all the changes to other 2 nodes. Okay. So raft method is actually very good for high latency and cross DC connection. So we prefer to have a raft method. So this is a GIF where we can see that the discovery is happening in a web GUI as well as in a command line client. So if we want to get a discovery done, we can just give our master node IP address and port number, and it will automatically discover a good view of your topology orchestrator. And in the same can be done with the command line as well. And this is how does the failover works for Orchestrator. So Orchestrator is very smart. It knows everything about replication, binlog, GTID, and everything. So if the restructure is illegal, like if it is not allowed, it will give you the error. It will not do it. So it is very smart, and you can do it again by web GUI as well as along with the command line as well. So here you see that you have to start the replication manually in the web GUI as well as in the command line. So if you want to make the replication start by itself, you can use graceful master takeover auto as an option, as an command to start the replication here. After doing the failover, we don't need to do manually then. So how does the orchestrator detect the failover? So naive approach was like when the orchestrator is not there, other tools what they do is if the master is not available, then do the failover. Okay. So in this situation, what can happen is it can cause a false positive if there is any network partitioning or something, like if the node has network disturbance, it will do the failover. But then how they improved was try to connect to master n number of times in n number of seconds, and try to connect it multiple times in n number of seconds. So what we are doing here, we are just wasting those seconds for getting our application up, right? Because our application is down until the failover is complete. So that's what it increases the response time. So but the orchestrator is very good. It uses a holistic approach for doing the failover. Holistic approach means it checks whole as a system, and it first check the master is available or not. If the master is not available, it will check all the replication whether they are able to connect to the master. If they are not able to connect to the master, it will straight away do the failover. This is how the orchestrator detects the failover. And the recommended settings for orchestrator for faster detection is recommended here. So slave, we should decrease the slave net timeout so that the replica comes to know as quickly as possible that the master is down, and the failover will be detected. And along with that, there is another, that master connect retry and master retry count should be, master connect retry should be decreased and master retry count can be increased as much as possible. So master connect retry needs to be decreased because when the failover happens, when the orchestrator detects the node that it is not available, master is not available. So at that time, what orchestrator will do is, what this option master connect retry will do is, by default the value is 60 for it. So we can set it to 1, so that every second the slave tries to connect to master and try to get the connection. So as soon as the master is available, the slave will connect and the orchestrator will stop the failover. So that is what the approach is here. So the candidate selection, how does the orchestrator select the candidate? So orchestrator will always try to select the candidate which is most up to date, and it will not promote the server without bin logs. Replication filtered server will not be promoted, and MySQL versions, it will make sure that the higher MySQL version server does not get promoted, because the lower version can fail the replication. And there is an option that we can register the candidate in orchestrator as well. For example, we want a particular server to be candidate, we can register the candidate in orchestrator. So these are the recovery, pre and post recovery hooks. This is executed once sequentially, and these are the events in the orchestrator that can happen at the time of failover. So what happens is, whenever the failure occurs, so the first is the failure detection. If you want any custom scripts to be executed for making some changes, you can add a hook, you can add a script, your custom script, and it will do at that event. In the same way, pre-failover checks, pre-failover process, graceful failover process, post-graceful failover process. So we can add the scripts there in the orchestrator configuration as needed. So orchestrator supports both automatic as well as manual recovery. So orchestrator, we need to configure here this option, recover master cluster filters, this one. So if your cluster is present in this options, it will do the automatic failover for this. Otherwise, if your cluster is not present, it will not do the automatic failover for that cluster. So something is still lacking here. Even though we are doing a failover, whether it is automatic or manual by orchestrator, we are still pointing our application by manually, and our application is not coming to know that what is the master server. So it is no use that we are doing auto failover. So, and no scaling distribution of reads and writes are happening. So we will introduce here ProxySQL. So ProxySQL is a proxy for database. It is actually a load balancer, and it can distribute the load through multiple MySQL backend servers, and it helps in query caching, rewrites, and it also facilitates read-write splits. And it has an easy configuration through SQL interface, and it also supports clustering as well. Sorry. So ProxySQL implementation can be done by two ways. Either it can be installed on application node itself to reduce the network hop, or you can have its own dedicated server as well for ProxySQL. So ProxySQL configuration comes in 3 layers. So it can be a memory, it can be run. It is in memory, and then runtime, and then on disk. So we configure it in memory, we load it in runtime, and then once it is good, we save it on disk. So these are the 4 tables that needs to be configured in ProxySQL. MySQL users will have DB users defined in it, and MySQL servers will have backend servers defined MySQL servers, and MySQL replication host group is the main table that will define the host groups of host group as well as the check type to move them into the respective host groups. And MySQL query rules will be there. We can write query rules to point to a specific database. So here now ProxySQL is a single point of failure. So ProxySQL also supports high availability. So we can also configure ProxySQL from since version 1.4.x as highly available. ProxySQL nodes watches each other configuration and in the checksum table, and if it does not match, it will update all the nodes with the updated values. So what do we have now? ProxySQL cluster we have Orchestrator cluster, we have our database. But does the ProxySQL talk to Orchestrator? So ProxySQL does not talk directly to Orchestrator. So ProxySQL will only will only check the read-only variable of the database, and it will put accordingly your servers under the host group. So for example, your databases are read-write. It will put all the database write databases in the host group for writer host group, and if the database is reader, then it will automatically place it in the reader host group. So what happens here? What is the problem here is that suppose if the network partitioning happens and Orchestrator does the failover, and both, for example, like replica has been promoted to master and it is set as a read writable as from the orchestrator. So orchestrator, when promotes the replica, it will set it as read write server. Okay, so the previous server was down because of network partitioning, and it comes up, the network comes up, and the previous server is also up now. So now we have two read write servers. So both of them will be placed in the writer host group at that time, and it can cause a split brain situation. So what we do, so orchestrator hook is the option that we can use to talk to ProxySQL. So what we can do is we can write the script and that can execute and remove the ProxySQL, which remove the MySQL which has been failed, and so stone it, shoot the other node in the head. So when it fails, just shoot the other node in the head and then just remove it, right? But even though we remove the server from ProxySQL, the ProxySQL hook, the orchestrator hook gets fired just only once. So it does not repetitively fire the hooks, right? So if the ProxySQL is not listening at the time when the hook was fired, it is still the same problem that ProxySQL has not got the information that the hook is done. So how do we solve that? So we introduce here Consul. So Consul is built on Golang. It is a service discovery tool, and it has a key value store in it. It is lightweight and native support in Orchestrator as well. So it is highly available too, and it has the 3 ports, that is remote procedure call, HTTP and DNS. So it does, what does the Consul do? It does the service discovery. It does also the health check status. It can load balance as well by checking the health check of the nodes. And it also has a key value store. It also has multi-data center deployment, and it also has a web user interface too. Very good. So Consul talking to Orchestrator. So does the Consul talk to Orchestrator directly? So what we will do is we will configure Consul servers on all the Orchestrator nodes. So what will happen is local install, right? So any changes happening to Orchestrator will send all the details to Consul. So right now what happens is when we do the Orchestrator config here, kv cluster master prefix to MySQL and master. So here is the address of Consul, and it will, when the orchestrator will submit the masters, it will automatically submit the master values to Consul, and it will be like we can fetch the values in this way. We can get it from IPv4 address, IPv6 address, host name, as well as the port. So this is how we can pull from Consul the values. So how does the ProxySQL receive this? So configure configure Consul on all ProxySQL nodes as the agent. Agent can be configured. N number of agents can be configured. Server is not needed. So server will send the information to agent, and the agent will keep updated, and agent will tell the ProxySQL that what all changes has been happened in the console. So how the agent applies the changes to how the agent Consul agent will apply the changes to the ProxySQL, that we will do using Consul-template. So the Consul-template is simple and powerful tool that populates value from Consul into the file system. So Consul-templates runs as a service. It can execute the commands as well. So this is just an example of how the template looks like. It gets the value from Consul, and it replaces the values and then run the command in here. It runs the command to ProxySQL. So Consul also support high available environment. It is also using a Raft consensus protocol. So leader in the same way orchestrator does, and leader is elected and all requests processed by leader. And this is how, since it is a Raft protocol, we can have a cross data center connections as well for Consul. So this is how our architecture look like now. So orchestrator cluster, we have 3 nodes. We have Consul servers on our orchestrator clusters. We have ProxySQL cluster. We have Consul agents installed on ProxySQL cluster. So what it is doing now, orchestrator cluster, when it submits the master, it goes to Consul server. Consul server updates Consul agent. Consul agent will update the ProxySQL cluster. Sorry. Okay. So orchestrator will write to Consul. Consul acts as a source of truth for ProxySQL. Consul-template can be used as a script. That's we discussed. Service discovery can be used along with DNS, using DNS mask for discovering, or you can either configure your own DNS as well for service discovery of ProxySQL. Since we are using multiple ProxySQL nodes, we can configure a service discovery using Consul for ProxySQL as well. So when the one of the ProxySQL nodes goes down, we can actually route the traffic to other 2 nodes as well, and all the nodes of ProxySQL will be in use. So this is just an example of configuring the service discovery with ProxySQL. We have defined here the ProxySQL 1. We have defined the check here. This is just an example check, and ProxySQL 2, the check is defined. So interval is 3 seconds. So every 3 seconds, it is trying to connect to that ProxySQL, and if it is not connecting, then it will route the traffic to another ProxySQL. So this is how the check look like in web interface of Consul. So this is proxy 1 and proxy 2. So node check is good, service check is good. So that means it is good. If there is any failure, it will show here as a failure. So how does the orchestrator hook works with Consul-template? So we have just tried to write a simple script, and how does it update the ProxySQL? We just tried to explain here. So the hook, you can see that post graceful takeover process, this hook we are using, and we are writing a simple script, that is this one, and we are using this magical tokens provided by orchestrator. So this magical tokens provided by orchestrator can be used here along with the script. So what I have done is, while writing the script, we have done echo $@ to just see what these arguments are: successor host, successor port, failed host, and failed port. So we will see in the next slide that how it works. So here is the logs of orchestrator hook when it gets fired. Okay. So okay, this is multiple. So here is the detected dead master on 192.168 and affected replicas 1. So we'll recover from dead master, and it has, after recovery, see here the successor host, successor port, failed host and failed port are visible here directly. And this is directly writing, the script is getting executed and it is writing to Consul directly the IP and port number of the failed host as well as it is writing. So what we are trying to do is orchestrator submit only the masters. Okay, it does not it does not submit anything for slave. So how do we update our ProxySQL for updating the slave reader group, right? So that is what we are trying to do here. So what we can do, the solution can be is we can create a directory in the console and place our all the key values of our replicas there, and once the key values are placed, we can write a script and modify so that when the failover occurs, the new host which is going to be promoted through orchestrator as a master will be removed from the reader group, and the host which is demoted can be added in the reader group, right? So that is what we are trying to do here. So you see that data return, and we have added this 192.168.103.10 and we have removed this new master 103.20. So this is how the Consul template look like. So Consul template, what it does, it reads the template and replaces the value from Consul source and destination. Do you see? So it creates a ProxySQL.sql file by replacing the values from Consul, and then it executes the command. So I have written the commands very clearly so it can be understood. So here is the logs you can see in the below. So here it is executing the command for updating the ProxySQL. So ProxySQL before the failover, if you see, so here it is the ProxySQL before the failover, runtime MySQL servers, host name like 20, 20 and 10 and 100. So first is this 20 is master, even though we still see this 20 because writer is also a reader is enabled in ProxySQL. So that is why the 20 is there. If we disable that, because if that is disabled, then you will not see that the failed over host will be available in this host group. Okay, so that is what I wanted to show here. So here is the flow control, the flow diagram, how the system is working. So ProxySQL is trying to monitor MySQL server. It gets the response from MySQL server. The app traffic, ProxySQL is serving the app traffic to MySQL and getting the response from there as well. And Orchestrator is trying to monitor MySQL server and getting the status. It is updating the master to Consul server, and then Orchestrator is also monitoring MySQL and doing the failover. And Consul server's job is to sync against Consul agent, and from Consul agent, this Consul agent is updating the Consul template, and Consul template is Consul agent is updating the Consul template, and ProxySQL Consul template is updating ProxySQL. So that is how the flow works. So conclusion here is Consul orchestrator ProxySQL saves the day. So every component is highly available. That is what our aim was for avoiding the single point of failure. And all components are open source and free and well supported by community as well as Percona 2. And it also works with Percona ExtraDB cluster, MariaDB cluster, and other MySQL setups too. So yeah, so even though the orchestrator supports automatic as well as manual failure, we don't recommend that it does we do automatic failure because it can be hazardous. Even though it is good, even though it will not take, even though it will benefit you that you don't have to get involved and it will do the failover, but still it can be some, there can be some problems while doing the automatic failover, and your DB can be problematic. Like the data can get problem. Whenever the whenever the manual intervention is there, we can actually take care of the DB properly and do the failover. I think the notification things has to be done very carefully here. Once we get notification, we can do it manually, but automatic is the solution, but it still comes with some price. I think that's it. If you have any questions. Yeah.
So when you're using Big C, you don't really need Consul and Orchestrator, ProxySQL will take care of everything like this.
Big C?
Yeah, like if you're using extra big cluster, you I mean
PXC, okay.
yeah, if it's Big C, you probably don't need a Consul and you don't need a failure, everything is taken care by ProxySQL, right?
Yeah, it is taken care by ProxySQL. Because that is synchronous replication, right? So we don't need to fail over. It is just if the node is out of there, ProxySQL will take care if it cannot connect. Any questions?
So, is it possible to use Orchestrator and Consul without ProxySQL? Like, can Consul notify your application conflict that the endpoint has changed?
Consul does not notify anything. ProxySQL is used. Sorry, can you repeat your question?
So let's say I configured the post hook for my orchestrator to update console, right?
Mm-hmm.
Can I have console agents running on my application server that can detect the change and change, say, my config file or connection string?
Yeah, that is possible, but ProxySQL is used for some different purpose, right? So if you want to, if you don't want to use ProxySQL, yeah, and also we are showing here the use of ProxySQL as a like your application needs to know what is the master, right? So you are trying to say that you will write in a hook that you will update the application connections, right? But then your application connections when gets updated, it needs to restart.
Yeah.
But here you don't need to restart. Yeah. It will automatically detect the new master and serve the traffic. So that is what.
And just going back to the network split scenario that we were talking about when it removes the dead master.
This?
Yeah. So if you also have like a reader list configured in server as a key value pair in the console server, can you
Okay.
update that as well, or it will just go through ProxySQL?
No, sorry, I didn't get again.
So say we have a dead master and we
Okay.
remove it from ProxySQL, right? Sorry, yeah, slave that cannot.
Using the hook.
Yes.
Okay, using the hook, we can remove the dead master. That's correct.
Okay. But in that scenario, there's no notification back to console because the console would just care about master.
No, notification to console. Why don't you? Why you need to notify console?
Say it also has a key value pair for MySQL readers or MySQL
Okay.
analytics reader.
Yeah, but when you are trying to update, like when you are trying to run a hook to remove the remove it from ProxySQL, right? But why do you need that when you have a console? Because Consul, when you are trying to run a hook, you are updating Consul, not ProxySQL. ProxySQL will automatically read connection. The Consul-template will is responsible to update the ProxySQL. So you don't need to actually touch ProxySQL from Orchestrator hook.
And hooks are only triggered in Orchestrator on the master failover or an intermediate master failover.
Yeah.
It doesn't care about replicas being way or being down. It doesn't
Yeah.
even report that.
So yeah, it also, I think, if it also fire a hook with replica as well, but that is on failure detection hooks, not this one. Yeah.
So, if there is some issue or some bug in we are hitting some bug in MySQL and MySQL is restarting after every 30 minutes, is the orchestrator smart enough that it will not keep on hitting
Yeah.
over and not keep on removing and Consul not keep on removing nodes from the
Yeah, so do you see this recovery period block seconds? So if it does the failover once and still your MySQL is crashing, it will block once the failover is done, it will block for 3600 seconds for the next failover. It will not do the failover till that time. So you can actually increase it or decrease it as per your needs. This is the orchestrator configuration.
And you can also manually acknowledge the
Yeah.
failover.
Yeah.
That's a good one. Like you say, this is good, you can acknowledge it, and then it will remove the block.
Yeah.
I actually have a follow-up question on acknowledgements, especially with automatic recovery. Is there a way to do the acknowledgements also probably automatically?
Yeah, it is possible through command line. So you can actually place it in a hook as well. So command line is possible, right? After failover hook, we can configure for acknowledging that. But why do you need to do that? Because if the failover happens, for example, it is automatic, then why do we acknowledge it automatically?
Because I think there was, and like I worked on this like 2 years back. There was this thing of like if you have more than 3 or 5 pending ACK recoveries, it doesn't do it.
Pending.
Failure acknowledgements.
Okay. Okay. Acknowledgement.
Yeah.
It is good to put some monitoring on that.
Yeah.
Is there any pending, any recovery that's unacknowledged? Like if it goes to a certain level that you get a page or something to look into.
So, any more questions? Good. Thank you. Thank you for.